Okay, so where's my mouse pointer? There we go. So here I just want to show you some stuff that's happened in Verse and in some applications I've been working on. I've been working for a long time on OpenGL 2.0, and some of you may know that I'm a member of the Architectural Review Board that actually builds OpenGL. OpenGL 2.0 has some really nice features for shaders. So I thought I would show you some stuff from that. This application is Connector, which I've run previous years. It runs a little funny. The objects bounce around. But basically, you can see the node structure here. We have two object nodes, and they're pointing to a geometry node, which contains a bunch of geometry that I modeled. And we have this node, which is a material node. This is another material node. And this is a texture, and this is another texture. So start by looking at this node, and we can see how they look inside. This is This is a node tree, which you might recognize from any 3D application, and it has an output, which is the starting point. And if you look at it, it's set to color because it outputs color. You have a blender, which blends two inputs, and one of the inputs is the incoming light, and the other one is simply just a color, which is white. I can change it to purple, for instance, and yellow. The funny thing with this is that the blender is set to subtract, so the object gets white minus the incoming light. So therefore, you get this weird shade of the light coming up from here, so it's black on the side that is lit, and it's white underneath where it should be dark. So then you get these nice, weird shaders that I like. But the shader I'm really going to talk about is this shader. I'm going to do some shader modeling. And I'm going to place it like this and click there. Now we can see the shader here. It jumps around when it rotates. I don't know why, but so let's look at this material. This material has an output, just like the other one, which has color, because I output the color. But it's connected to a texture, and the texture is set to red, green, blue. And I have a geometry here, which says vertex, 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 which means that I bring in the vertex position of each position of the vertex, and then I use that as a mapping tool to map the texture onto the surface. So now let's add a blender. And let's insert that between these two, right? And let's set to add, and then I insert a color here. So now I add a color, and you can see that when I start changing the color values, you can see that I move the texture over the surface, right? So this is Y, and this is X, and this is C, and nothing happens because it's a flat texture, right? So moving the texture inward and outward doesn't do any difference. So this is a cool sort of feature. So let's make this material a little bit more complicated. Let's add some light, because this object is not lit, right? It's just the color of the texture. So let's add another blender and place the blender in here for the output, and then connect this one over. Right there. And now you can see that it cares about light. The thing is that right now they're added together, which means that the texture we have is sort of the ambient term. We don't want that. We want it to multiply. So now it looks more like we're used to of having an object being lit and shaded with a texture. On top of that, let's do something more. We're starting to get a little bit more complicated shader here, but we can move along and make it quite a lot more complicated. We can add another color, and we can add another blender. We can put the blender right there, and we can add in some color here. Now you get sort of an ambient term, right? You got sort of flat lighted. And I can change the color of the flat lights, make it green. Now it's sort of turquoise, or a very ugly green, like that. So now I've made a pretty awful material. You go blue or purple or whatever I want. And as you see, the shaders update in real time. So you can sit and build your material and see in real time what it's going to look like. These little spheres that you can see also show you what it's going to look like. You can look at the output and see the final image. But that's not on your object, right? Whereas here you can see what it actually is going to look like. Now I'm going to do something really fun, which is I'm going to bring in this output. And this output is set to displacement. So I'm going to move that over to the texture. And all of a sudden this object, I'm going to do a little twist here. Let's see if we can get it. Playing about a bit. I think that's correct. I don't see any displacement. Funny. Color. There we go. It has some update bugs. So now you can see it's all displaced with a single color. So the entire object just gets very fat. Looks kind of ugly, right? So I'm going to move this over and connect it to the texture. And now it gets deformed depending on the color of the texture. So it looks kind of violent right now. So let's change it a bit. Let's insert another blender before it. Right there. And then let's add a color. I think it's going to go even worse right now, like that. It's starting to become really ugly. But I changed this blender from add to multiply. Now gets smaller. So now I can simply, this one should be there. Here we go. So now I can simply change the parameters of this color because the color is now multiplied with the size of the displacement. So I can use my slider to sort of displace the object. And obviously more fun is, I'm going to collapse a few. You might remember we had this one, which we used to move the texture. So now I actually move the displaced texture over the surface, and you can see how it moves some blobs. So, move down a bit. So you can see how it sort of shifts over the. I can change this to, now it's add, I can change it to multiply. And then instead of, when I pull these, I actually scale the texture. You can see I scale in X and scale in Y. So this is a pretty fun way of playing with textures and things. And all is OpenGL shaders. And I guess all the artists went in there, so they can appreciate this. But so if you're all you programmers, I think I have this is the standard out from the application.
Yeah, this is going to appreciate it when we package it so that they will use it and it works.
Okay. That's, can I quit this application somehow? So let's see if I can. Here's the standard out. So it outputs quite a lot of junk, but from within the junk you can actually find. Oh, sorry. Oh no, please don't. So here you can actually see the shaders. And every time I make a substantial change to something, it generates a new shader like this and compiles it in the graphics card driver. so that it runs on the graphics hardware. So you can see here what's going on. I have all my parameters, the normals, the environment maps, the texture I'm using, the geometry, the two colors, and they're all, here's computing the light sources and then adding together all the colors in the correct way. Here we go again. So, and this is the shader for the vertex shader. So you can see I'm normalizing the light and putting through the geometry parameters and all that thing. So it's kind of a fun way of building shaders if you're interested in shading building. So that was my presentation on that.